Hello all and welcome to this third and hopefully final video where we review the 2019 Maths B exam. I want to start off by first pointing out a couple mistakes in the second video. There's two mistakes that one of the students found. I just want to say thank you to, that was Eddie Nguyen who found these mistakes. So well done, and I think it's just proof in point that everyone does make mistakes. So don't be afraid to be making mistakes. Always put in an attempt at the question. If you're not sure you will get the correct solution, starting and making the attempt might lead you to realizing how to solve it halfway through. So never stop, always have a crack. So the first error is in question 7a. I said the answer was 215.92. I got that error because I hadn't written very clearly. This cubed here above the 3 was written pretty rough and it looked like a squared when it should definitely be a cubed. So that should be a cubed. And then when you cube that 3 instead of squaring it, you actually get 254.47 centimeters cubed. So question 7a, that's the correct answer. And then also in question 10b, 5 take away 21 is negative 16. I left off the negative symbol right there. So it should be negative 16 on 18, therefore negative 8 on 9. So yes, thank you to Eddie for finding both of those mistakes. But let's get going straight away. Now with question 11, we'll do question 11 through 18. Determine if the following matrix products exist. If so, state the order of the matrix produced and compute it. What is this question assessing? This question is assessing matrix multiplication checks, so knowing the orders of a matrix, checking if you can multiply them, and then also being able to multiply. So this question involves a couple key bits of knowledge. The first bit is, the way I do these problems is I write above the matrices what their orders are. So this matrix here is a 1 by 2, and then it is this one is a 2 by 3. This one here is a 2 by 3 by a 1 by 2. And this is a 2 by 1 time, and this is a 1 by 2. Remembering we always count how far down we go and then how far across we go. We drop then slide, I guess you could think of it when looking at a matrix to find its order. What we're then going to do is look at the middle two numbers. And so we look at these ones, and if those numbers are the same, then they can be multiplied. So for this one, we could say the product exists. Product does not exist. Does not exist. And then this one, the product does exist. Now with that, how big is the matrix, the resulting product? Well, that'll be the outside numbers that we haven't circled. Well, actually this middle one can't exist, so we get to ignore it, and then that. So what we end up with, product exists and it will be a 1 by 3 matrix. Product does not exist, so we can't write anything down, and then this will be a 2 by 2. So let's go ahead and find them. So we get a 1 by 3, so give myself plenty of space to fill this in. So we take the row multiplied by the column. So take the row of the first matrix, multiply it by the column. So we're taking row multiplied by the column, then multiplied by the column, multiplied by the column. So 1 times 1 is 1, plus 3 times 0 is 0, so 1 plus 0. Then the second one is 1 times 2, which is 2, plus 3 times 3 is 9. Then we have 1 times 0, which is 0, plus 3 times 2 is 6. So we get 1, 11, 6 is the resulting one. This one, we don't get anything. And now we're going to be taking our rows multiplied by the column. Take our row multiplied by the column, and we get a 2 by 2. So this is quite an interesting one. So 1 times 1 is 1, multiplying the first row by the first column. We're going to do this element over here. So that is in the first row but second column. So first row, second column. So we do 1 times 3, that gives me 3. Bottom left is 3 times 1, which is 3. Then bottom right is 3 times 3, which is 9. We're done. A little hint, and this is looking towards being smart and efficient, and there's nothing wrong with this, is taking guides from the assessment. Okay, especially going to 11 and 12, you want to work efficiently and smartly, is have a look, for this style of question, have a look at the marks down the bottom. It is likely the ones that are worth more marks probably mean you have to do some more work, and then the one that's not worth as much mark might be there's less work involved. So just a little bit of a hint there that might guide you on which ones do have a product and which ones don't. Question 12, two events A and B are such that probability of A is equal to 0.4, probability of B is 0.3, and the union of those two is equal to 0.6. Find the intersect. We then need to find the intersect of A, not B as well, and then we need part C to state if the parts A and B are independent. So part A is looking at using the addition rule. Part B will be maybe making a two-way table or something first to then allow us to help us make find that intersection, and then events, checking if events A and B are independent. That's just knowing what conditions would hold if something is independent and then being able to check that. So find the probability that A intersect B. Well, the addition rule says that the probability of A union B, and this is on the formula sheet, is equal to probability of A plus the probability of B, take away the probability of the intersect. So we can now get that the probability of A intersect B, just rearranging this, taking that over this way and then this one over this way, is equal to probability of A plus probability of B, take away the union B. So we're going to get 0.4 plus 0.3, take away the 0.6, that gives us 0.1. Done. Okay. Find the probability of A intersect not B. We could do a little two-way table, and I might do that now to help explain some of this. So we have A, not A, B, not B. Left off the totals here. So probability of A is 0.4. Probability of B is 0.3. We found the intersect of both of them is 0.1. So we could start filling in the rest of this table. That must be that 0.2, that's 0.3, that must be 0.6, 0.7, 0.4. So we filled that in by only knowing the first bits that we knew was that all probabilities must add together to be equal 1, and then we'd found already the intersect from over here. So we had that. It's asking for find the probability of A intersect not B. Well, we're asking for A intersect not B. That gives us equal to 0.3. Done. Just by making a two-way table. So that's pretty handy. Part C, are events A and B independent? Justify your answer. So to check if two events are independent, there's a rule that if they are independent, if I can spell today, it follows that probability of A times by probability of B is equal to the probability of, let me make sure I got this right, is equal to the intersect of the two of them. Is equal to A intersect B. If they're independent, this is true. So let's do that check. Given the information we've figured out or we're given, we get 0.4 times by 0.3, and that is equal to 0.12. Yes, is equal to 0.12, which does not equal 0.1 from in part A. Therefore, they are not independent because that rule hasn't held true. When we multiplied these two together, we got that, which does not equal this, which we found over here. So they are not independent. Question 13. Pizza delivery time of a shop is normally distributed. Okay, so this is a normal distribution question with a mean of 45 minutes and a standard deviation of 15 minutes. So straight away I'm just going to write down that information, that the mean is 45 and the standard deviation is equal to 15. Some of you may have seen this symbol before called sigma. That's normally what's used for standard deviation. Sometimes when it's first introduced, they also use S is equal to 15, just saying S for standard deviation. But I'll use sigma from here on out, just to be clear. Between what two times do approximately 2/3 of times lie? So key bit here is the word approximately 2/3, and this question is looking at knowing the distribution spreads or probability spreads within a normal distribution, and we know that the mean plus or minus 1 standard deviation is approximately equal to 68% of the sample or the population. Now 68% is pretty darn close to 2/3. 2/3 is 66.666%, on and on and on. 68, well, that's pretty darn close. So we need to find between two times that are 1 standard deviation. So that's going to be 45 plus or minus 15 minutes, which follows on that is 30 to 60 minutes. Okay. So therefore, worded question, try and answer with a worded response to make sure you're answering the question properly, because some people forget to actually explicitly answer the question. Approx 2/3 of deliveries is between 30 and 60 minutes. Done. What percentage of pizza trips would estimate to take longer than 45 minutes? So this is coming down. I'm going to draw a little quick normal distribution. It's like that, and we have our mean at 45. We have 1 standard deviation, 2 standard deviations, 3 standard deviations. And it's asking percentage of trips that take longer than 45 minutes. Well, this is actually quite a nice easy question. It is asking for what's the probability of everything here greater than 45 minutes. Well, since 45 minutes is our mean and a normal distribution is a symmetrical distribution, that means the top half and the bottom half are reflected, approximately 50%. 50% of deliveries are longer than . So that's that. If a pizza delivery person delivers 600 pizzas in 6 months, how many of these trips would be expected to take less than 15 minutes? Okay, so let's do another normal distribution picture. We have 45, 1 standard deviation we already figured out was 30, 2 standard deviations would happen to be 15, so that's minus 1 standard deviation, this is minus 2 standard deviations. We are trying to figure out how many people are down here, how many deliveries are down there. we know a whole half is 50%. We know, and I'll just write this out, plus or minus 1 standard deviation is equal to 68%. So and I'll draw this in just quickly between there and 60. In here is 68%. Because it's symmetrical, we could say to there is actually 34%. So if we just looked at the negative component of it, if we just went to 1 standard deviation, that is 34%. It's half of it, because half of it has to be in the top half in here, and then of course the other half of the 68% needs to be in the bottom half. So we can use this trick of splitting it into just the negative component. So we know plus or minus 2 standard deviations is equal to 95%. So from that, we can assume, well, because it needs to be symmetrical, if we only have the bottom half, the negative 2 standard deviations, that needs to be 95 on 2, which is 47.5%. Okay. So 45.75% exists in the bottom, in the negative 2 standard deviations. So where is that zone? That is going from here to here, from the mean down to 2 standard deviations. That blue zone is equal to 47.5%. But I don't want the blue zone, I want the part after it. And this is where knowing that the bottom half is 50%. So if we want the area past negative 2 standard deviations, well, that is equal to 50. Take away the 47.5 in the blue zone, that leaves me with 2.5%. Now, go back and read the question. In a pizza delivery person delivers 600 pizzas in 6 months, how many of these trips would be expected to take less than 15 minutes? Well, 2.5% isn't our explicit answer. We need 2.5% of 600. So the deliveries is equal to 600 times by 2.5%, which gives us 15 deliveries. Now, would I expect you to draw a diagram and then break down, especially this first standard deviation? No, that wouldn't be expected, but certainly having this diagram and identifying, coloring in which zone you want, figuring out maybe, and then using components of that, breaking it down. This is pretty much how you're always going to have to do a problem where it's like less than 15 minutes. So if you're working in this bottom half, or it might ask, how many deliveries took longer than 75? Well, that would be the same. That would be that top end. You'd have to break it down this similar approach and figure out the halves of the standard deviations. Question 14. Barry has a 0.6 chance of going to the gym if he went to the gym the day before. He has a 0.03 chance of going to the gym if he did not go the day before. If Barry goes to the gym, what is the chance he does not go to the gym over the next 2 days? Okay, so the way I'd suggest going about this is you could write it out in an equation, is that it's equal to the probability of, what's the chance he does not, if he's gone to the gym, how to write this with notation, but it's equal to the probability of going to the gym, it's the chance he does not go to the gym. It's probability of not going to the gym, given that on day 1 he did go to the gym, plus him also not going to the gym, given he didn't go to the gym on day 2. So this is day 2, day 1, this is day 3, day 2. That's how you could sort of write it with notation. That's a little bit complex and could be confusing. I think a simpler way to come at this problem would be to use a tree diagram and just figure out which branch this is telling the story. So he goes to the gym or he doesn't go to the gym. He goes to the gym or doesn't go to the gym. that. Okay. And it says if he goes to the gym on the first day, so we're going to here, so I'm going to actually just ignore the rest of this. What's the chance he does not go to the gym on the next 2 days? So he doesn't go to the gym, so we go to here, and he has to not go to the gym again. So this story, we've done this. We've done this, we're guaranteed we're here because he's gone to the gym. What's now the probability he doesn't go to the gym on the next 2 days? Well, he has a 0, this is where we put in our data. 0.6 if he did, so that's a 0.6. He has a 0.3 chance of going to the gym if he did not go the day before, so that's a 0.3. Well, no. Oh, no, I've made one mistake. Let me just reread this, get it straight in my head. He has a 0.3 chance of going to the gym if he did not go to the day before, so that's a 0.3 down here. Oh, yeah, we can just fill it in. So this is so if he has a 0.6 of going to the gym on day 2, if he went on day 1, so that's day 1, this is day 2, day 3 over here. If that's 0.6 along here, that must mean that is 0.4, and now we just need to figure out the probabilities for day 3. So if he has a 0.3 chance of going to the gym if he did not go to the day before. So not going to the gym if he did not go before, that is 0.3. That must mean that's 0.7. Now the whole story, what branch do we want? We want, he's been to the gym already, that's guaranteed. He does not go to the gym, he does not go to the gym. So to find the probabilities going along a branch, we multiply them, so that is equal to 0.4 times by 0.3. So our probability is equal to 0.12. Done. So a little confusing breaking that down. That question, what that question is more testing almost is, it is testing just knowing to multiply along a tree branch or using these conditional probabilities. But it's more about analysing the problem and really breaking down what that information is telling you. And you saw then even I got a little bit confused because I was trying to work too quickly and talk too quickly. I had to stop, slow down, really reread it and figure out how the problem, how that data could be applied to a tree diagram. Question 15, the sales of a shop selling plastic garden chairs can be modelled by the equation blah, the sales in dollars for n items of furniture. So sales is the amount of money taken in sales for n number of items that we sell. The cost to make each chair and additional expenses can be, so the cost associated with making said chairs is equal to 4n plus 12, where n is the number of chairs. How much does it cost to make 5 garden chairs? So this whole question, question 15, it's a bit long, 7 marks. This is looking at being able to use function notation, a bit of financial maths. We'll be drawing the two equations together and making a quadratic, and then in part D we'll be solving that quadratic. So how much does it cost to make 5 garden chairs? So the cost to make 5 garden chairs is equal to 4 times by 5 plus 12 is equal to 20 plus 12 is equal to $32. How many chairs are needed? How many chairs need to be made to sell $72 worth of chairs? So we're trying to find S of how many chairs we need so that we get $72 in sales. So we just substitute that into our S equation for S. So we get 72 is equal to 2n plus 3 all squared minus 9. Add the 9 to 72, that gives us 81 is equal to Now let's go the other way. We want to make our quadratic equal to 0, and then we can solve it, because it happens to be, check out this, 0 is equal to 2n plus 3 all squared, take away 81, which happens to be 2n plus 3 all squared, take away 9 squared. What have we just gotten? We have got something squared, take away something squared. We've just got a difference of perfect squares. So that can be written as the solution. That's the same as 0 is equal to the first thing, so our first square, 2n plus 3 plus the second square, and then the same bracket, 2n plus 3 take away the second square. This is that pattern where if we have a squared minus b squared, that it can be written as a plus b bracket a minus b. So the first square is what I mean by a, which is the 2n plus 3 because it's all squared, and then the second square in our case happens to be 9. That can be substituted in. So that's the difference of perfect square, and now we could rewrite this as 0 is equal to 2n plus 12 bracket 2n minus 6 using the null factor law. It follows on that 2n plus 12 is equal to 0 or 2n minus 6 is equal to 0, so we get n is equal to negative 12 divided by 2 is negative 6, or n is equal to, add the 6 to the other side, 6 divided by 2 is equal to 3. We reject a negative answer. We can't sell a negative amount of chairs. Reject negative. Therefore, sold 3 chairs. Okay. Part C. The shop's profits can be modelled by subtracting costs from sales. Write an expression for the shop's profits in the form p equals an squared plus bn plus c. Okay, so this comes down to just understanding how businesses work and what the difference between sales profits and costs means. Cost is, of course, how much money you have to spend to do something. So supplies for the chairs, labour, rent, all those sort of things can tie into a cost. Sales is the total amount of money people hand you for buying things. So it's all the money your cash register takes in. Now we just need to be aware that that's not all the money we're actually not going to make that much money, as in that's not how much money is going to go into our bank account, because we have to use some of that sales money to pay the costs. So what is left after we pay costs, so we do our sales, take away our costs, what is left over is what we call profit, which is what we actually as a business get to take home. So P is going to equal S take away C in this case. So now we just write in the equations is equal to 2n plus 3 all squared minus 9 take away, and I'm going to put the second equation. I'll even put the first one just in brackets so it's a bit obvious to see. That's our S equation, and then I'm going to take away our cost equation, and a lot of people made mistakes here by not putting it in brackets because we're taking away the whole equation, so we have to be really careful with our signs. So now we can have a look at this a bit better. 2n plus 3 all squared, take away 9, take away 4n plus 12, because the taking away the negative 12 turns into positive. We can expand that 2n plus 3 squared. Well, we're going to have to get it in standard form. So that becomes 4n squared plus 3 by 2n is 6n times by 2 is 12n plus 3 times 3 is 9. So I've just used the shortcut expansion to expand this square, which says if you have a plus b all squared, that will turn into a squared plus 2 times by a times by b plus b squared. So 2n squared is 4n squared. 2n all squared is 4n squared. Then to get the middle term is 2n times 3, which is 6n times by the 2 is 12n, and then this 3 squares to give us 9. So I've just used that shortcut there. We then get the rest of it minus 9 minus 4n plus 12. We now get 4n squared. 12n take away 4n is plus 8n. 9 take away 9 is 0 plus 12, so we get plus 12. So that's our profit equation. That tells us how much money we'll actually make per chair we sell, taking into account the costs associated with making each chair. How many chairs need to be sold to break even? Okay, to meet the cost. Well, if we want to break even, that means we're not making any money, but we're also not losing any money. So to break even, that means our profit is equal to 0. So we get 0 is equal to 4n squared plus 8n plus 12. Handwriting's getting a bit messy. Okay, so we need to solve this. To solve this, we need to factorize. The first thing we should ever try and do when we factorize, and hopefully my class is shouting this back at the video at the moment, is take out the common factor. Don't jump to the cross method, don't jump to the quadratic formula, don't jump to inspection. Is take out the common factor first. So we get 0 is equal to 4n squared plus 2n plus 3. So 0 is equal to n squared plus 2n plus 3. And that is going to be much easier to factorize than trying to use the cross method. So we get 0 is equal to n bracket n. So I need two numbers multiplied to give me 3, and I had to give me 2. 1 and 3, but copy everything down properly. Looking like, because 3 can only be made up by 1 and 3, but to get positive 3 it needs to be the minus 1 and minus 3, or positive 1 and positive 3, and neither of them give me a positive 2n. So that's a little bit of an issue, which means there's not an integer solution to this. We can't do it via inspection, so you could do it then either your options from here are completing the square or using the quadratic formula. Personally, I am a big fan of the quadratic formula. N is equal to negative b plus or minus the square root of b squared minus 4ac on 2a. It is equal to, I'm just going to check if I've made a mistake anywhere, because I would have thought we would sell a whole chair here. That looks right. Oh my god, I wrote down the original equation wrong. Okay, this is handy. I apologise for those in C who may have realised straight away. It's 4n plus 12 was the original equation, so I need to go back and do some work here. So that becomes negative. And this can happen in a test where you realise getting through in the way tests, knowing how tests are written and what you expected, and it's not a problem when it's asking how many chairs to be sold. If you're saying I need to sell 2.33 chairs, well, you can't really do that, so all of that is wrong. That bit there will be wrong, so I'll come back to all of that. So the mistake is I put that as a negative initially, and it's supposed to be a positive, so negative take away the 12. And up here is going to be a takeaway 12. So that turns into the negative 12 there. Okay, better. So that's a minus 12 down here. That's a minus 12 down there. Oh, minus 3. There we go. That's going to be better. 0 is equal to n bracket. Now this works. That's going to be a plus 3 minus 1. Therefore, n is equal to negative 3, or n is equal to 1. We reject the negative. Therefore, must sell 1 share to break even. Now, for those of you going into, well, we do this in methods and specialist anyway, but it's normally with more complex functions. But for those of you going into general and further, you do heaps of financial mathematics and what's called linear programming, which is doing stuff like this, having equations for costs, for sales, but then maybe also having equations for factory maximum, so having maximum amount of chairs that you can make in a time and all sorts of other things. And so you'll do more complex versions of this and lots of that. Question 16. The following two matrices show the number of groceries purchased over 3 weeks and the cost of each item bought. Give a matrix indicating the cost of the groceries. So we need the cost of the groceries purchased week by week. Well, we can get that by looking at this first matrix. It tells us how many items we bought per week, and then it also tells us the cost for each of those items. So we could do, let's call this matrix I. This is, or maybe matrix P for purchases. This is matrix, not maybe P for purchase. I want to come up with. I just don't want to use the same letter twice. Here, G for groceries, P for prices, and we want to find the cost. So cost is equal to the groceries we bought times by their price. So we can get 24, 10, 2. So I've said C is equal to our cost, which is what we need to find. 3, 18, 7, 2. Now, if you just didn't use the letters, that's fine, or assign them to the matrices, but that's completely fine. Just knowing that we can solve this problem by doing multiplication. 1, 3. Okay, can we do this multiplication? This is a 3 by 3 times by 3 by 1. That is, look at the middle numbers. That's a 3 and a 3. Yes, we can do it. We look at the outside numbers. That tells us our answer. So our answer is going to be a 3 by 1 matrix. And allow plenty of space. So we multiply the row by the column. So this first will be 24 times by 0.4. I'm going to need to have some more space. Plus 10 by 1 plus 7 by 3. We do it again for the next row. So we get 12 by 0.4 plus 5 by 1 plus 3 by 1. No, 3 by 3, sorry. And then we do it for our third row by the column. So we get 18 by 0.4 plus 7 by 1 plus 2 by 3. Put all of these in your calculator and see what you get. So 24 by 0.4, 9.6 Plus 10 plus 7 by 3 is 21. That's 40.6. Second, 12 by 0.4 plus 5 plus 9 is 18.8. And then 18 by 0.4 plus the 7 by 1, which is 7, plus the 2 by 3, which is 6, we get 20.2. 20.2. So how do we read this? What did we ended up doing is we took the rows, which is our weeks, and multiplied them by the prices down this way. So our resulting thing is looking at those two column names, I guess, together. This tells us that, well, this is week 1, this is week 2, this is week 3, and this is the total prices that we paid, or the cost. So that's telling us the cost of the groceries purchased week by week. That's what that matrix tells us. That's how you read it, is you look at the name of the row from the first matrix, the name of the column from the second, and then you can apply that to the final answer, and that's what those cells are telling you. What is the total cost of the groceries over the 3 weeks? Well, we know the cost per week, so we just add them together. Total cost is equal to 40.6 plus 18.8 plus 20.2, which is equal to $79.6. So total cost is that. Hey. That question is probably one of the hardest matrixy questions you're going to come across, because not only is it using matrix multiplication, you had to come up with the multiplication yourself, understand what that multiplication would give you, what that final matrixy, this one here, what that matrix actually means. So that's a pretty tricky matrix question, and personally I consider one of the harder questions on the test. Question 17, consider the following square-based pyramid, giving some measurements there. Show that the distance PM in exact form is 1 centimeter. Okay, so we need to find PM, which is that bit there, when we are told PR is 2 root 2, so PR is all the way there, is 2 root 2, OV, there is 5. Okay. Rightio. Now, it is a square-based pyramid. That means these in here are right angles. So if we look at this PQR triangle that's being made, and if we look straight down on it, that's not very to scale. If we look straight down on it, it looks like that. That is 2 root 2 across there. That's Q, that's R, that's P. So how am I going to go about this? Well, I want to find PM, which is this distance along here, which happens to be halfway. So if I could find PQ, I then halve it, that gives me PM. So my goal first is to find PQ. Now looking here, we have a right angle triangle. I'm just going to delete that bit out, and I'm just going to call this side length X, and since it's a square pyramid, both those sides are X. So I get X squared, or if we just, actually I'll go back to the regular formula, is the hypotenuse is equal to H squared is equal to A squared plus B squared. So I get 2 root 2 all squared is equal to X squared plus X squared. So 2 root 2 squared is equal to 2 squared root 2 all squared, which is equal to 2x squared, because I have x squared plus x squared, so I have 2 of them. So that gives me 2 squared is 4, root 2 squared is 2, so that's just times by 2 equals 2 x squared. So I get 8 is equal to 2x squared. So I get 4 is equal to x squared, so x is equal to plus or minus the square root of 4, so x is equal to 2 because we reject the negative. We can't have a negative when rejecting negative. So x pq is equal to 2, so pq is equal to 2, pm is equal to pq divided by 2 because it's equal to half, which is equal to 2 divided by 2, which is equal to 1. Okay, as required. That's how we show it. Very good. Calculate the volume of the pyramid in exact values. This question, because it starts with a show that, as soon as you see one of these and it's to show that, that's giving you this answer will be needed for the next sections. So we don't want to punish you that if you couldn't figure this out yourself, that's why we're telling you to show that it's 1 centimeter, is that we're giving you this number. We're telling you that that number there is 1, so that even if you can't do part A, you can do part B and part C. So as soon as you see show that question, even if you struggle with that bit, don't give up on the rest of it because we've given you the number that you're going to need for the rest of it. So we had that is 1, that's 1 there. So we want to find the volume in exact values. So the volume of a pyramid is, we go all the way back to the start to get our equation. The volume of a pyramid, rectangular prism, is volume is equal to length times width times, oh no, that's rectangular prism. There's square pyramid here. 1/3 base squared h. Volume is equal to 1/3 base squared h. Okay. Now, with h for this is the actual vertical height and not the slant height. That's slant height because I always remember that the volume and surface area of a pyramid is really annoying because the h refers to different things, but for volume it's referring to, let me pick a different color, I'll use red. It's referring to this height here, the vertical height, which we're actually given as 5. And we know that the base all the way across, since we're told PM is 1, we know that that distance all the way across is 2, and same up here, that distance is 2. So, our volume is equal to 1/3, and we had B is equal to 2, and H is equal to 5. We get 2 squared times by 5 is equal to 1/3 by 4 by 5 is equal to 20 on 3. And we can't simplify that any further, and we need units, and we're given our measurements in centimeters, so that is equal to centimeters cubed. Calculate the total surface area of the pyramid in exact values. Okay, so TSA is equal to pyramid here, b squared plus 2bh. B squared plus 2bh. B squared plus 2bh. And this is now knowing the pyramid formula, the total surface area. Let me change color up here. Let's go this green. That when it refers to h, that is referring to actually the height of the triangle on the side. That is not a terribly straight line, but that's when we're dealing with total surface area. That's what that h means for total surface area. So we need to find that height there. So this is actually takes a fair bit of working out. because to find that we need to do some more Pythagoras theorem. So we know that that is 1, 2, we can assume that across there is 1. That would be right angles. Yes, that would have to be 1. That's across 1. So that there's 1. So we end up with a triangle. Looking at the side view, we have 5, we have 1, and we have a H. Let's come down here. 5, 1, H. So H is equal to the square root of 5 squared plus 1 squared is equal to the square root of 26. So that's our H value. So now we can finish this off. That we know B was 2, so we get 2 squared plus 2 by 2 by root 26. So we get 4 plus 4 root 26. Now 26, can we simplify that all? Can we divide by 3? No. Can we divide by 4? No. 9? No. So that's it. That is centimeters squared. Correct 2 decimal places, while TSA is equal to 4 plus 4 root 26 is equal to 4 plus 4 shift root square root 26 is equal to 24.39607, which is roughly equal to 2 decimal places, 24. The 6 means we round up the 9, which goes to a 10, so it actually rounds to 24.40 centimeters squared. Done. Last question. We're getting there. 52 minutes. A ball is selected without replacement twice from a bag, so without replacement, containing 5 red balls and 3 blue balls. Draw a tree diagram representing this. Okay, so we have red, we have blue, we have red, blue, red, blue. So it's without replacement. So the probability of getting red is 5 on 8. That's 3 on 8. If we pick a red one, then we have 1 less red, so we get 4 on 7. While if we pick a red first, we haven't affected the blue, so we still have 3 on 7. We get a blue first, we haven't affected the red, so there's 5 on 7. We get a blue first, we have, so that means there's only 2 on 7 left. Okay. It doesn't say we need to list the final combinations or final probabilities. You could do that if you wanted to. But since it doesn't explicitly state it and you always crunch for time in exams, I wouldn't worry about it. What is the probability of selecting a red ball and then a blue ball? So since it says then, that means order matters. So we're finding the probability of red, then blue in that order. That is equal to 5 on 8 times by 3 on 7. Just multiplying along the branch. We've gone to this red, then that blue. So 5 on 8 times by 3 on 7. So that gives me 15 on 7 eighths, 56. Can we simplify that? 15 divided by 56. No, that's as simple as it can get. Find the probability of obtaining at least 1 red ball. So at least 1 red ball. Probability at least 1 red is equal to all the combinations that have 1 or more red balls. That is equal to the probability of red red plus the probability of red blue plus the probability of blue and then getting a red. which is this combination, this combination, this combination. So you could find all of those, and I'm going to show you a shortcut to do this in a second. That's even quicker. So that is red is 5 on 8 times by 4 on 7 plus probability of red blue we just found was 15 on 56 plus probability of blue red is 3 on 8 by 5 on 7. 3 on 8 times by 5 on 7 is equal to 5 by 4, that's 20 on 56 plus 15 on 56 plus 15 on 56 is 30, 20, 50 on 56 is 25 on 56 divided by 2 is 28. We get that. The other way we could figure this out, the probability of at least one red, the only way we don't get one red is probability of not blue. Okay, we just can't get blue because every other combination has at least one red on it. So that is equal to not getting blue is the same as 1 take away the probability of getting blue. So that's 1 take away 3 on 8 by 2 on 7. 8 by 2 on 7. And that gives us the same answer finally as 25 on 28. So either of those two ways will work. If you recognize getting at least one blue ball means just you can't get blue, you could use this knowing that the 1 minus blue. So there's a way to go about it. If after the second ball is selected 3 yellow balls are added, find the probability of selecting a yellow ball. Okay. So after the second ball is selected, we add 3. So we've done. We now have, we're going to add in a yellow ball. So the trick here is knowing just what it's asking the probability of getting a yellow ball. Doesn't matter what's previously happened. All we know is that since we don't care about what's previously happened, we could have blue, red, yellow, and we know there's 3 of them have been added. And how many balls? Well, we started with 8, take away 2 because we've done the first 2 selections, so we've got 6 left, plus the 3 yellow. That means we have 3 out of 9 now that are yellow. We don't know the combination of the blue and reds that make up the other 6 balls, but it doesn't matter for this. It's just find the probability of selecting yellow ball. So for the third ball, we can see from sort of what I was just explaining, we have 6 black, blue. Blue or red left. We have 3 yellow left. Therefore, the probability of yellow is equal to 3 out of the 9 total balls, which is equal to 1/3. Given a yellow ball is selected, find the probability a red ball was selected first. Given a yellow ball was selected, find the probability that a red ball was selected first. This is a doozy of a question. A lot of people get sucked in to trying to do the giant diagram. They do this and then keep it going. Find all the probabilities and then try and calculate what it is. The thing is, a yellow ball being selected in this third go has absolutely no impact back here. It has absolutely no impact. They're independent. So this question is asking us to find the probability that we've got a red ball in our first go, given that a yellow is selected in the third. So let me change my notation a little bit just to make that a little bit clearer. We're trying to find the probability that we get a red ball in the first go, given that we've picked a yellow ball in the third go. Okay? Picking a yellow ball in the third has no impact back here, has absolutely no impact. They're actually independent events. So that is just equal to, knowing the rules of independent events, that is just equal to, well, what is the probability of getting a red ball in the first go? Because the yellow has absolutely zero impact on it. And we know if we go back to our original tree diagram, the probability of getting a red ball in the first go is just 5 on 8. And that's how we do that problem. So it seems really complex, and you could go and do all the tree diagrams and find all the combinations and add up all the combinations that have a red in the first go, that have a yellow in the third go, but it makes no impact. They're independent. Well, that's it. Sorry for the long video, but some of these, to explain how to do them, takes longer than actually just doing them. As always, it's roughly about a minute a mark that you need to be able to do this whole exam at. If you find any more mistakes, please let me know in the comments. Always willing to recognise that we do make mistakes. Thank you very much. Email me if you have questions.